Welcome to Physical Science, Week 14. This week, we're going to be looking at precipitation, thunderstorms, and tornadoes and hurricanes. Now, I want you to read Chapter 8, be sure to stop at Weather Maps, do the on-your-own questions 1 through 7, and experiment 8.1 at home, which we'll be looking at later. For your discussion question this week, were you able to see the lightning in the home experiment? Do you like watching lightning during storms? Why or why not? Read through and be sure to comment on some of your peers' threads. Now, one quick note. Next week is Thanksgiving, and we are not going to be having a formal class. Instead, I want you to use that time to get all caught up on your work because everything is due December 10th. Anything not turned in by December 10th will be graded as a 0. If you have already contacted me because you have a special circumstance, you and I already have a different agreement. So let's go right into this week. We're going to begin by looking at precipitation. There are 5 common types of precipitation: rain, freezing rain, sleet, snow, and hail. Rain is the most common type of precipitation. Drops of water are called rain if they're at least a ½ millimeter in diameter. Drizzle is when drops of water are smaller than that. Mist is when drops are even smaller than that. Drizzle and mist fall from stratus clouds. Sleet is ice particles smaller than 5 millimeters. Sleet happens when raindrops fall through a layer of air below 0 degrees Celsius, or freezing. As they fall, they'll freeze into ice. Sleet can make sidewalks and roads very slippery. Freezing rain are raindrops that freeze when they touch a cold surface. A smooth, thick layer of ice can build up on a surface during an ice storm. The weight of the ice can break tree branches and cause them to fall on power lines. They can also make sidewalks and roads extremely slippery, even more slippery than sleet. Hail are round pellets of ice. Any larger than 5 millimeters in diameter are called hailstones. Hail only forms inside cumulonimbus clouds during thunderstorms. Hail starts as an ice pellet inside a cold region of a cloud, and powerful updrafts can carry the hail up and down through the cold region. A new layer of ice forms every time it passes through the cold region. Once it becomes heavy enough, it will fall to the ground. Hail can cause tremendous damage to crops, buildings, and vehicles. Now, the picture you see below here is not actually hail. Rather, it's graupel. Unlike hail, which are raindrops that freeze and collect moisture every time it goes up and down through the cloud, graupel is snowflakes that go up and down through the cloud. It creates a far more porous crystalline structure and is not quite hail. It's like halfway between snow and hail. Now that we understand a bit more about different types of precipitation, we're going to watch a short video about thunderstorms.
Off on the horizon, they rumble. Rolling across the land, they darken the skies to then spark fire in the darkness, letting out an unmistakable roar.
You didn't specify what video quality it had to be. I mean, if you don't specify what video quality it has to be, if there's no internet to do it, YouTube will automatically drop down to the most efficient video quality. At 144 pixels, you can't see hardly anything.
Off on the horizon, they rumble. Rolling across the land, they darken the skies to then spark fire in the darkness, letting out an unmistakable roar. Thunderstorms are rain showers accompanied by lightning and thunder. While violent, these weather phenomena are common, with about 2,000 occurring at any moment worldwide. There are 4 major types of thunderstorms: single cell, which are small, weak, and isolated storms; multi-cell, a common type of storm that includes a cluster of thunderstorms; squall line, a collection of storms that can form a line hundreds of miles long; and supercells, the most intense kind of storm capable of producing tornadoes. All thunderstorms form when warm air in the lowest layers of the atmosphere rises, called an updraft, this air causes water from the Earth's surface to evaporate and carries the moisture upward to form clouds. The clouds then build and grow, sometimes as tall as 10 miles high. The clouds darken as they fill and become heavy with water. Cool, dry air from the upper layers of the atmosphere, known as a downdraft, then pull this moisture downward, causing it to fall as life-sustaining rain. In addition to helping sustain life, thunderstorms also help maintain the planet's balance of energy and electricity. When energy, specifically in the form of heat, causes water to evaporate, the heat is carried upward with the water vapor. As the vapor condenses and forms water droplets, it releases the heat into the higher altitudes of the atmosphere and cools the Earth's surface. Thunderstorms also help regulate the electrical balance between the atmosphere and the planet. As clouds in a thunderstorm develop, excess positive and negative charges form within them. At a certain point, this buildup of opposite charges leads to the transfer of electrons in the form of lightning. This transference of electricity occurs so quickly that it breaks the sound barrier, a phenomenon that produces thunder. While thunderstorms are necessary for maintaining balance in the atmosphere, they can also be hazardous. Lightning strikes create fires. Excessive rainfall can cause flash flooding, and high-speed winds from tornadoes can destroy homes. Meteorologists study weather systems to try to predict the occurrence of thunderstorms and help ensure the safety of countless communities.
Now that we know how thunderstorms work, let's look at them in some more detail. So before we move on, let's look at what weather and climate are. Weather is the state of the atmosphere with regards to the temperature, moisture, pressure, wind speed, and precipitation at a specific time and place. Weather can change rapidly, as we saw just previously. Unlike weather, climate is far more predictable. Climate is defined as the long-term average weather in a particular region. Let's see in more detail what the difference between weather and climate are.
If you're like me, you know what your perfect day looks like, weather-wise. Sunny, rainy, snowy, whatever. Personally, I love it when it's cool and cloudy, like just cold enough to wear a sweater. You probably know that weather has something to do with how hot or cold it is outside. But really, there's a lot more to it than just temperature. So grab your sunglasses, your rain boots, and your most colorful scarf, because today, we're talking weather. Let's start with a big and pretty basic question. What exactly is weather? Well, weather is the condition of the air, or the atmosphere, on our planet. But the thing is, even though there's only one atmosphere on Earth, the weather isn't the same all over the world. There are many different factors that can change the atmosphere in a certain area, and together they determine what the weather is like from one minute and from one place to the next. These factors include temperature, humidity, wind speed and direction, and lots of other things. But when you're talking about the overall weather patterns from a certain region of the world, you're talking about the area's climate. Weather is the minute-by-minute changes in the atmosphere. Climate is what the weather is like over a long period of time in a specific area. Now, the weather is constantly changing, all the time, every day. Think of the weather as being like that one friend of yours who can never make up their mind about what movie they want to see or what restaurant they want to go to. Just because it's beautiful and sunny outside when you wake up, that doesn't mean you won't need an umbrella before the day's over. And raining is just one of the things that weather can do. Rain, of course, is just a form of precipitation, or water that falls from the sky. It happens when droplets of water in the clouds, or sometimes ice crystals, get heavy enough and fall to the ground. If they're crystals, the warm air near the ground will melt them as they fall, forming liquid raindrops. But do you want to build a snowman? Another common form of precipitation is snow. Snow is just ice crystals that don't melt into liquid water as they fall. Another snow-like form of precipitation is sleet. It's what happens when ice crystals fall toward the ground, partly melt, and then refreeze again. But other kinds of weather can be way more severe, and the most common kind of extreme weather is a form I'm sure you're familiar with: Thunderstorms. A thunderstorm can happen when strong winds make drops of water and pieces of ice collide and break apart inside a storm. This causes electrical energy to build up, which creates a little something called lightning. But all of this rain and snow and sleet I've been talking about, that's all just weather. And while weather can change in a few hours, a region's climate takes hundreds, thousands, even millions of years to change. So how can we better understand the difference between weather and climate? How about we send Cartoon Sabrina on a little imaginary trip for a month? Okay, here she is at her destination, Yuma, Arizona. Let's pretend it's the 5th of the month. On this particular day where Cartoon Sabrina is, it's warm but very cloudy and a light rain has been falling on her, sorry me, all day. Since clouds and rain are what the atmosphere has to offer on this particular spot at this moment, and they can go away at any minute, those conditions are, the weather. Now let's fast forward to the 10th of the month. Hello, sun. Looks like Tiny Me won't be needing an umbrella today. How about the 15th? More sun. The 20th? Still sunny. The 25th? You guessed it. Sunny with a chance of, well, sunny. And finally, on the 30th, the sun's still shining. Little Sabrina, I hope you packed your sunscreen. So what does this quick time lapse of a month in Yuma tell us? It tells us that Yuma, Arizona is a pretty sunny place. In fact, on most days, it's one of the sunniest cities on the whole planet. So the city's weather patterns existed before Mini-Me arrived and will continue after she leaves. In that case, you could say that Yuma has a sunny climate, even if its weather on a certain given day happens to be rainy. Now you know that weather is much more than just temperature. It's the condition of our planet's atmosphere, and it's constantly changing. You also know that weather and climate are not the same thing. But I saved the extreme stuff for last. The severe weather stuff, that is. You'll have to tune in next time to learn more about tornadoes, hurricanes, and blizzards.
A severe storm is a dangerous weather event that causes damage to buildings, disruption, or even death to human and animals. Examples include hail, blizzards, ice storms, extreme winds, wildfires, thunderstorms, and tornadoes. Severe storms are caused by changes in temperature, moisture in the air, a difference in air pressure, and thermal lift. Now we're going to watch the second part of that video about specifically severe storms.
Hi guys, welcome back. Today we're going to talk about... Sorry about that. Today we're going to talk about... Are you finished, Thunder? Thank you. Thunder is pretty excited because today's episode is all about it. Well, to be more specific, today's episode is all about severe weather. But before things get all snowy, windy, and rainy in here, let's bundle up and ask ourselves the big question. What exactly is severe weather, and how is it different from regular weather? We know that weather is a condition of the air or atmosphere on our planet. Severe weather is the same thing, only more extreme. Extreme! But what does that mean? How do you know when weather is severe or extreme and when it isn't? Well, severe weather is any dangerous act of nature that puts people, animals, or buildings at risk. Some light rain probably wouldn't count as severe weather, but a thunderstorm with heavy rain and lightning would. Tornadoes, blizzards, hurricanes, floods, and droughts are other forms of severe weather that can be dangerous to humans. But the more you know about these weather events, the less scary they seem. Let's start with tornadoes. A tornado is a fast-spinning column of air that stretches all the way from a thunderstorm cloud down to the Earth's surface. With wind speeds of up to over 300 kilometers an hour, tornadoes have the power to pick up and destroy everything in their path. While not quite as windy as a tornado, blizzards are storms with blowing or falling snow, high winds of their own, and cold temperatures. Hurricanes, or typhoons, are storms with high winds and heavy rain that start over warm ocean waters and bring lots of water with them. Speaking of lots of water, let's talk flooding. Floods happen when too much rain forces streams, rivers, and lakes to overflow, sending lots and lots of water where it doesn't belong, like your backyard. A drought is sort of the opposite. Think a lot less water, or no water at all. Droughts happen when an area doesn't receive enough rainfall, drying up rivers and lakes, killing trees, and ruining crops. All of those forms of severe weather have a big impact on the biosphere and the geosphere. How so? Let's find out. I'll conjure up some different types of severe weather to see exactly how shakeups in the atmosphere can impact the biosphere and the geosphere. Severe weather can be dangerous for people, obviously, but beyond affecting humans in the biosphere, severe weather can also affect plants and animals too. Take a drought. After very long spells without enough rain, this nice mountain pond will become smaller and maybe even dry up entirely. That means less habitat for the animals that live in the water, like ducks and beavers. But it also means less plant life around because plants need water too. And fewer plants mean less food for animals like deer and elk that feast on them. But what about the opposite problem? What about too much water in the form of heavy rain? Really strong thunderstorms can sometimes bring lightning and high winds that can damage trees, maybe breaking off some of their limbs, uprooting them, or even setting them on fire. This is bad news not only for the tree, but also for everything that lives in it. And finally, even the ground, as solid as it might seem, can be reshaped by severe weather. Strong, recurring floodwaters act like powerful rivers and can actually wear down rocky formations like mountains over time. And sometimes big flows of rainwater can cause a slope or hillside to collapse in an event called a mudslide. The atmosphere interacts strongly with the other spheres of the environment, particularly when it's cooking up severe weather. It can even move things in the biosphere and reshape the geosphere. So now you know how to tell if weather is severe or not. Ask yourself, does it put life or property at risk? Does it have a major impact on the biosphere and the geosphere? If the answer is yes, you're not dealing with normal weather patterns. Severe weather might be less common, but it has a much bigger impact on the world around you. Anything to add, Thunder? I guess that means we're done.
So we learned that a thunderstorm is an example of a severe storm. Thunderstorms are small, intense weather systems that produce heavy rain, thunder, and lightning, as well as strong winds. Regions will experience thunderstorms when warm, moist air rises into cold air. Although thunderstorms can occur at any time of the year, they are most likely to happen in the afternoon or evening hours during spring and summer months. Another example of severe weather is a tornado, which we've received a lot here in Oklahoma. Although they do not usually last very long, tornadoes are very dangerous. They contain an immense amount of energy. How do tornadoes form? During a severe thunderstorm, the wind can blow at different speeds, heights, and directions. This creates a rotating column of air. The updraft can tilt the rotating column upward, creating a funnel-shaped cloud, predictably called a funnel cloud. When the funnel-shaped cloud touches down, it's called a tornado. If you would like to see a tornado, which I personally don't recommend, your best bet is to travel to Tornado Alley. On the boundaries of Tornado Alley include central Texas and northern Iowa, from central Kansas to Nebraska and to western Ohio. While this has actually shifted here in recent years, tornadoes are still more common in these regions than they would be in other regions. Another example of severe weather, which we had looked at earlier, is a hurricane. This is a picture of Hurricane Isabel taken from the ISS. Hurricanes form in a similar fashion that storms on land do, but in a far more powerful sense. You can see that the entire storm is rotating around the eye. Which direction the storm rotates depends on which hemisphere you're in. Before we finish up and look at your experiment, we're going to be watching one last video about hurricanes versus tornadoes and what their differences are.
What's the difference between a hurricane and a tornado? I'm Storm Team meteorologist Jason Myers, and they are both a testament to Mother Nature's fury. They both spin counterclockwise in the northern hemisphere, and they both cause loss of life and property each and every year, but they are far from the same thing. For one, they both form in very different ways. Hurricanes form in warm ocean waters. Moisture evaporates, rises, and begins to circulate. As the storm grows, winds continue to speed up, and eventually an eye forms around the middle. Tornadoes, on the other hand, spawn from thunderstorms. Rotation in different layers of the atmosphere within a thunderstorm create a funnel cloud that eventually reaches the ground. But neither one of these is necessarily more superior than the other. Difficult to compare, but something we can compare: size. Hurricanes can be hundreds of miles in diameter. The biggest tornado ever recorded had a damage path of a little more than 2.5 miles, but most are only 300 to 400 yards. In fact, tornadoes have been known to spawn inside a hurricane. Advantage: hurricane. Now round two. What about wind speed? Hurricanes may be bigger, but tornadoes still pack a punch for their size. Hurricane force winds range from 74 miles an hour for a weak storm all the way up to 157 miles an hour or more for a catastrophic Category 5. A weak tornado starts out with winds around 40 miles an hour, but an EF5 tornado has winds anywhere between 261 to 318 miles an hour, much stronger than the strongest hurricane force winds. Point goes to tornadoes. Tie ball game. Next round. What does more damage? Tornadoes do all their damage using those extremely strong rotating winds. Hurricanes, however, come with a triple threat. They use strong winds, heavy rains, and storm surge, bringing huge waves crashing on shore, causing more flooding. But even so, tornado and hurricane activity can vary from year to year, but study after study has shown that on average, they're both equally damaging and deadly. This one is a draw. But what lasts longer, has the endurance, the staying power, the stamina? Hurricanes last for a few hours to a few weeks, and the average falls somewhere in between. Tornadoes are on the ground anywhere between a few seconds to maybe a few hours for an especially strong storm, but the average is somewhere between 2 and 15 minutes. Hurricanes can go the distance. Tornadoes and hurricanes vary on warning time as well. Since hurricanes take so long to form and do a lot of traveling before reaching land, people usually have plenty of notice to take cover or evacuate. Watches are typically issued 2 days ahead of time, and warnings are issued 36 hours before anything happens. Tornadoes are completely different. Watches are sometimes issued an hour or two ahead of time, and the average warning time for a tornado is 13 minutes. Just enough time to get to a safe place. Tornadoes are definitely scarier for this reason alone. And now we've ended up with a tie, so it's settled. Don't mess with either of these storms.
So to do your discussion question this day, you're going to be doing your experiment at home first. Let's look at experiment 8.1 now. To do this experiment, all you're going to need is a balloon and a dark room. Blow up a balloon and hold it in your hand. Then rub it back and forth against your hair and hold it up against your knuckles. Do not let your knuckles touch the balloon. If you did it right, you should see a spark. This spark is a discharge of static electricity, much in the same way that lightning does. To take this experiment a little bit further and maybe have a bit of fun, try rubbing the balloon up against some of your parents' hair or maybe your pet. Be sure to ask your parents first. That's all I have for you today. Be sure to get some of your stuff caught up and enjoy Thanksgiving next week. And we'll meet again on week 16 to wrap up the semester.